Welcome back, everyone. We've got 2 more papers to go. Our next paper is by Zohar Eitan, who's on the Faculty of Arts at Tel Aviv University, and is another student of Lenny Meyer's and Eugene Narmour's. And he's another student who has actively engaged with Gene's theories, and that's what we're going to hear about today. So, Zohar.
Thank you. Well, like Justin, I attended those scary classes at Penn in '84, but I was scared twice. First, like everybody, I was scared because of the complexity and difficulty of Gene's theory. But that was the easier part. The harder part was several weeks later when I thought, well, maybe I'm beginning to get it. And then Gene enters the class and says, well, you remember what I told you last week? Forget it, it's wrong. So what I've learned from Gene, among many other things, was that a scientific model, a scientific theory is a living thing, an evolving thing, and it keeps changing. And maybe all our presentations today, mine included, would contribute something to this evolution of a very viable model of music cognition. Now, another thing, if you read my abstract, forget it. Because, as you see, the title is different and there's a little of that abstract here, but much else. And most of what I'm going to talk about is indebted to other people, to Gene first, but also to Frank and Bill and some other people, David sitting here. Okay, so a brief overview. As we have heard several times, in the implication realization model, the bottom-up processing works on supposedly hardwired and independent parametric primitives that are structured by syntactic parametric scaling for each primitive. Now, and you've heard a little bit about this from Frank. Before, we know that auditory dimensions interact in perception, and they affect those primitives. And we also know that auditory dimensions interact with dimensions of other modalities, like space and motion and brightness and size and so on. So the question I'm going to ask is, what does the interaction of perceptual dimensions, both within the auditory domain and across a sensory mode, suggest concerning the parametric primitives that the theory suggests, and bottom-up processing based on them? So I'm going to go through this fast because you have heard much better presentations of the basics of the theory today, but this is the points that would be relevant to my later discourse. So the theory suggests 2 independent expectation systems: a bottom-up system, which is automatic, innate, hardwired, brute, and a top-down, learned system in which the implications are generated by schemata learned from our experience, primarily our musical experience. And the bottom-up system processes parametric primitives which are hardwired, and though they interact with one another and later with top-down schemata, initially they're independent. And in melodic processing, as we know, there are two such primitives. Undirected interval size, that is interval size with no regard for direction, up and down, and separately register direction, the contour, the direction of melodic motion. And there are two syntactic parametric scales, the I scale, the intervallic scale, and the vector scale, the register scale, V scale, which represent the structure of these primitives. And as we know, the main implications of these parameters are that small intervals imply continuation, that is similar intervallic motion in the same direction, while large interval imply reversal, that is that the next interval would be smaller and in a different direction. Okay, we know that. Now what do we know? And this would expand on Frank's context effect that we've heard about the last hour. What do we know about interaction of auditory dimensions? Some examples of many. We know that in speedic classification tasks, when you have to classify, say, pitch at high and low and ignore loudness on timbre, you can't really do this. And there is a very significant interaction between these dimensions. This is the work of Larry Marks and collaborators. Another example, we know that the changes in pitch contour affect your temper perception, Marion Balls, and we know that intensity, physically speaking, and loudness, perceptually speaking, it's perceptual correlate, and patterns of intensity and loudness affect the perception and short-term memory of pitch. We know that from several different studies by Neuhoff and McBeat, and also from, for instance, recent study by Johnson and Jones that show that when intensity changes in a predictable way, it affects not only your expectation for how loud the next note would be, but also your expectation for how high it would be. So specifically, how is the perception of pitch interval, melodic pitch interval between successive tones, affected by other parameters? We know that it's affected by register, that is by whether the interval is in the high or low register. We know that from work of Russo and Thompson that you heard about before, and a related finding is that in one of the earliest studies by Cuddy of the IR principles, one of the factors that very strongly affected melodic expectation was pitch height, which is not one of the principles. The higher the continuation tone was, it was tended to be rated higher. So what about pitch direction, which is an independent primitive in the theory? Well, several studies indicate that pitch direction interacts with register in the perception of interval size, and generally intervals are perceived as larger when the target pitch, when the second pitch is farther from the middle range. That is, ascending intervals perceived as larger in the upper register, descending in the lower, also Frank and Bill. And there is a comparable result in work by Ronnie Granot and mine that measured the melodic tension of short melodic sequences, and it shows an interaction of pitch, direction, and register, which is pitch rises convey more tension, but only in the upper register, while pitch falls convey more tension in the lower register. And some of this, and this is an important point, some of this may be explained by the distribution of pitches along the range, maybe particularly, but not only the vocal range, as we know from the work of David Eugene and Paul from Hippo, which is rarer and less expected target tones, that is, both in the register extremes, may be perceived as psychologically more distant, and then the interval is perceived as larger. Now, that's not all. Pitch intervals are affected, the perception of pitch interval size is affected by intensity. That is, another one of Bill's papers, and which is supported by others. Pitch intervals are larger when intensity and perceived loudness are higher, and when they're increasing in crescendo. And it is also affected by timbre, by the spectrum of the partials, which is if the target tone is congruent with regard to pitch and timbre, it is both higher and brighter or sharper when the interval is perceived as larger. And two well-known facts that show that the perception of pitch intervals is also affected by duration. That is, if you have the free note succession and you alter the inter-onset intervals between the second note and both others, then you get that listener perceives larger pitch intervals when temporal intervals are larger, and also the reverse. That is, listener perceives larger temporal intervals when pitch intervals are larger. So what can this imply regarding the basics, specifically the bottom-up basics of the IR model? And specifically, is interval magnitude a parametric primitive given this data? And we have seen that perceived interval magnitude, that is not only the implications of interval, but the very perception of this supposed primitive is affected by many auditory variables, and perhaps we're talking about a composite percept rather than a primitive which is determined by frequency ratios. And perhaps most importantly, perceived interval magnitude is affected by pitch direction, which may indicate that the two basic bottom-up parametric scales of the theory are not independent at a very basic level. They interact from the very beginning. Now, perceived interval magnitude may be affected by statistical learning, as David's group has shown, so it may not be so hardwired or innate. And actually, there are some studies by Purvis and Schwartz and others that suggest that the very rudimentary process of pitch extraction is affected by lifetime learning of the environment. That is, what we extract are not the acoustical signals per se, but those that we expect would be a part of the auditory object in front of us. So, problem regarding bottom-up. And another problem is that unexpected changes may be perceived as more distant psychologically than expected changes, as we have shown from some of the effects of tessitura and loudness. So what we may see is that realization or denial of melodic implication may affect the very perception of the parameters upon which these implications are themselves based. So we have a kind of top-down, bottom-up loop, and I would say something about a field I know nothing about, but maybe some other people do. Brainstem learning may be associated with this kind of loop. It would be nice to hear something about this. So, we can't finish a presentation without acronyms, and I'm going to suggest 2 acronyms. MT intervals, which are the log function-based intervals that we all know. And I would suggest that these are top-down derivatives of tonal schematas, of the organization of keys, modes, ragas, and so on. And one kind of support for this are many studies of Jay Dowling and collaborators that show that we have a very poor representation of intervals per se when melody is atonal or tonally ambiguous or quite new and so on. We use contour. And a different kind of support for this is personal. When I remember my grapples with Modus Novus, the atonal solfege book, when I was an undergrad at the composition department in Tel Aviv. Suddenly, and I was very good at tonal solfege, but suddenly I realized that everything I know supposedly about intervals, perceiving and producing melodic intervals, are hardly any relevance to the context before me. Intervals, we can learn intervals per se, but as many of us know, it's a very tough learning process. It's far from natural, far from easy. Okay, now that's the MT intervals. Now the certified medical doctors, or MD interval, the multidimensional intervals that I hypothesize are multidimensional measures of melodic event distance, and similarity and difference between melodic events, which weigh many factors, as we've seen, both auditory and cross-modal. If I'll have time for this, I'll talk about this in the next few minutes. And as measurements like the many studies that I quoted, and also earlier psychophysical studies like those of Stanley Stevens, who came out with the Mel scale of interval, show this kind of perceived intervals may be quite different in the way they are perceived and in their relationship than the empty intervals. So could a syntactic scale of MD intervals, which assesses the similarity and difference, the degrees of implication of closure in Narmourian terms, be constructed and tested? That might be an interesting challenge, and specifically given the feedback loop, which means that there are no stable primitives. The primitives keep changing because, due to learning, due to top-down influence. That's tough. I don't know how to do this, but I think Eugene would, and we will hear this. So, how am I going with time? Great. Okay, so this is a bit of my original presentation, which I rewrote completely in the last 3 days. We know that pitch maps in perception not onto our auditory parameters, but onto features of non-auditory modalities like vision, touch, kinesthetic aspect, and so on. For instance, higher pitch is perceived as smaller, as denser, as brighter, as especially higher, really, than lower pitch. And you can read summaries of this vast research in my chapter in this book, which is the first script dedicated to this honorable person, which you can, I guess, browse later outside. And also in studies by Spence, Larry Marks, in a study by Renette Timmers and myself, tons of data. Now, you know that also the interval size and register direction map onto aspects of bodily motion, and Frank talked about this, and much of the stuff has been done in his lab, onto velocity and magnitude and direction of motion. So pitch intervals are not only dependent on our auditory dimensions, they may interact in interesting ways with non-auditory dimensions. So, and what's important to stress is that some of this correspondences, though language expresses it, we talk about high and low notes, dark and bright sound, and so on, are most probably not related, okay, I'm fine, not related specifically to language and culture, and there's a host of studies with infants and animals that indicate that very small infants can respond to the correlation between pitch direction and spatial direction, going up and down in space, to the correspondence of pitch and visual shape, the Bouba-Kiki thing, pitch and luminance. This is not babies, this is chimpanzees. Higher pitches are brighter and lighter. Pitch and physical size, many studies by Morton and others, including music-related studies by David's lab. So some of this stuff is very deeply ingrained. I don't know if it's innate, but easily and early learned. And there are emerging studies that show that not only the auditory cortex is involved in pitch perception, but parts of the motor and visual cortex, and specifically, and this is what I'm going to end with almost, cross-modal correspondences according to emerging theories and empirical studies may be represented by general bipolar magnitude scales, scales in which one pole is more than the other, and this is a model that was initially suggested by Walsh in 2003, and a recent summary of research is by Bourne and Associate. And this, the suggestion is that this system, located in the inferior parietal cortex, is a source of cross-domain mappings which may involve both time, all of which involve magnitude, scale of magnitude, and it may involve both time and space, and auditory dimensions like pitch. Now, could such representation serve as a basis for cross-domain syntactic scales, measuring the magnitude and direction of perceived distance between musical event, our medical doctor intervals, multidimensional intervals? I don't know. There is no closure to this presentation except thanks. So I want to thank Jin for teaching me to rethink everything, including his own models, and for designing a great non-closure theory, one that keeps generating new implications for many of us. And thank you for listening.